Hello, listeners. Welcome to our podcast called How Stars Work. Me, Diego Armenta, and my imaginary co-host named Eric. Say hello, Eric.
Hi, everybody.
We both will be discussing the breathtaking stars and how they work, and their history. I will be discussing the first half, and Eric will finish the rest of the podcast.
Where do we start?
I guess we could start with nebulas. So to start, a nebula is a giant heap of clouds made of gas and dust, and is a reason for stars' birth. A nebula typically looks like this. The way the sun comes into play is by the gas and dust collect due to strong forces of gravity, as all the dust and gas causes the material in the center to heat up. After this process, it creates protostars.
Wow, that's interesting. Wait, if the sun is in the protostar stage, how does it become the sun?
By nuclear fusion. For nuclear fusion to occur is when two light nuclei form a single heavier nucleus. While in this process, it releases energy because the total mass of the resulting single nucleus is less than the mass of the two original nuclei. The leftover mass is turned into energy. Oh, and another important thing about stars, the two primary elements that make up stars are helium and hydrogen.
Nuclear fusion sounds dangerous. How do stars never pop or burst?
There are two forces that keep the star in check, which are inward gravity pushing the star, and the outward pressure created by the heat due to the fusion reaction. Oh, and another important thing to mention is our sun, low-mass stars, and high-mass stars.
Do stars have life cycles?
Yes, they do. Low-mass stars and high-mass stars have different life cycles. Well, to start, a low-mass star can have longest life of stars and typically have orangey red colors to their stars and use hydrogen fuel less. And for high-mass stars, they have lowest lives of stars and use all their hydrogen fuel. They have bluish-white tint to them.
That's cool and all, but what's happening inside the star? Like, is there creatures or something?
No, but there is elements being made inside the star. Nuclear fusion is the cause for the elements, and the star's energy source. The cause for new elements is when hydrogen atoms is forced together to make heavier elements, such as helium and carbon.
I'm learning so much right now. Wait, hold up. How long do stars stay alive for, like in their main sequence stage?
Typically, stars stay alive at 10 billion years in their main sequence stage. Hey, Eric, do you finally want to take over?
Yeah, but I don't know a lot about stars, so I'm most likely to just use Google or something. So I remember you talking about the hydrogen fuel, so I kind of searched up what happens when this hydrogen fuel runs out of the star.
Okay, go on. Tell us.
When stars do run out of hydrogen, they turn into red giants. It also depends on the mass of the star. For low-mass stars, they turn into red giants, and for high-mass stars, they turn into super red giants. I also found out when low-mass stars die, they end up as white dwarfs. When high-mass stars die, they end up as neutron stars or even black holes. This usually occurs at the end of their life cycle. That is crazy, dude.
Hey, Eric, search up what supernovas produced.
When a supernova happens, it releases a massive amount of neutrons which can help heavy elements such as gold and other such heavy elements be produced. I even found out what happens after a supernova explodes or even when a star dies. I found out that when a supernova goes off, the leftovers of a supernova is a neutron star or even a black hole. There's still a mass amount of mass basically left.
I think that concludes everything for today, Eric. Thank you, and come back for later how stars work. Maybe we'll go even more in depth. Who knows?
Bye, guys.